Hello, 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 hello. Alright guys, so we can hear screen is shared. So our goal here is to learn about linked lists as try to learn C# 2. I have a little project set up, so it should be a pretty simple thing to do. Get a little bit of feedback, should be okay. Alright, well, as we're learning the ins and outs of C#, we're going to be learning about linked lists. So as our little quick test, we do a .NET run, which should run the program.cs, which says, does this work? Which we're good. And we're going to go ahead and use the browser to find out what are linked lists. What are linked lists? Now, I understand what linked lists are, where you point to a different piece of memory, but I want to learn how to create linked lists in C#. Create linked list C#. So there's a linked list has scores a bunch of nodes linked together, so you need to start with a simple node class, public node next, public object data, not even understanding this. Here we go. A linked list is a linear data structure which stores the element and the non-contiguous location. The element in a linked list are linked with each other's using pointers, or in other words, linked list consists of nodes where each node contains a data field referencing a link to the next node in the list. In C# linked list is a generic type of collection which is defined in a systems.collections.generic namespace. Okay. It is a doubly linked list, therefore each node points forward to the next and backwards to the previous node. It is a dynamic collection which grows according to the need of your program. It also provides fast inserting and removing elements. Alright, so let's learn how to use this. So we're going to go ahead and use that. I'm going to pull some other screen for right now. Using system.collections.reg. Go ahead and find C#. Install linter for that. Oh. Alright. Next part of C is linked list. Type of linked list. Linked list name is new linked list. Type of linked list again. Guessing you do something like a string. Yeah, so use a string, so one string points to one node points to another with a string data type in it. Let's go ahead and start with that. I am kind of using a little bit of the stuff that it's giving me. So using system, so class, let's call this linked list, static public void main. I think you have to capitalize this apparently. Alright. And if you're looking to see where I'm getting that from, just going directly over here. I don't want to copy and paste. I'm trying to learn something from scratch so I can get used to the syntax as well. Alright, so we're going to call this linked list string. Right, let's call it names. Will be fine. Is equal to new linked list string. Then you close off the parentheses and then the semicolon at the end. And it looks like you just add directly to the linked list using add last, which should point to the end. So let's go ahead and try that out just as it says. We're going to call this names. Add last Stefan, which is my name. Last. Go ahead and add another name. And one more, just cause. A Mickey Mouse. Let's see what options this gives us. So we get add last, find, clear, copy to equals removes, get type add after, add first, contains, find last to string, add before, remove last, get hash code, and a bunch of other stuff. Oh wait, no. Get hash code, remove first, get enumerator, on deserialization, bunch of fancy, nice little things right there. Console, right line. Doesn't say, names. Go to the next line. So it looks like it's using a simple loop for each loop. For each string, name, and names. You just do console dot right line name, I believe. .NET run. Okay, that's cool. So looks like going through a linked list is obviously O of n. Space is O of 1. Need auxiliary space is O of 1 at least. Alright, let's dig a little bit deeper into this. I'll pull this back over here. Oh, sorry. I want this right here. This is doing the same way I just did. Okay, but now we're removing some things. Then we're trying to see if it exists basically by after we remove it. Move another thing. Checking to see if it actually removes. Removing the first item of the list, which is a good test. Checking again. Removing the last item of the list, which usually I thought that's how it would work, just okay. Then you can actually clear out the entire linked list. Okay, cool, that's good. I'll do that then. Okay. Let's just go ahead and do this like that. Dog, cat, mouse. Dexter. Alright, so we got a little bit more. Because original names. Let's not do it like this. Do a space. So now we're gonna do our remove. So when we're removing it, first one that it removes is where remove is saying this dot first. So in my mind it's the first element or the first node to the linked list. So let's go ahead and do that. I'm gonna do names dot remove names dot first. Just grab that as well. Sorry about that. Removed. The font. One. We can set this remove my name because you see. Okay, hold on. Let's clear this up a little bit. Alright, so you can see the clear delimiter with the white space, and my name's removed. Alright, so you can also remove by value, which is good. Let's go ahead and do that. First off, let's go ahead and copy all that, paste it. We're gonna go right above this. This is where we're gonna remove it. And let's go ahead and remove dog out of here. Alright. So we should do names dot remove dog. And just so you can see how that's happening, we have, this is what we just did before, and right now we're moving it by value, so row hit should map back to here. So now we should have no dog and no stuff on this next one. Remove dog. .NET 1. Alright, so we do not see dog. Like we see right here, looking good. Alright. The next part is you just remove the first value. Really handy. We already did that with the remove, then you specify the linked list that you already specified here, then you specify first. So it's basically the same thing and in a different way. Right. So I'm gonna do name.remove first. .NET 1. So originally we had Natalie for this, and now Natalie's gone. Okay. looks good. Obviously, you gotta do a remove last, just like Emery does it at pop. Remove last. Should only have 2 values now. Or is it 3 values? Well, let's open this up then. Okay, good. Okay, so we had 4 before. Let me just remove Dexter by doing the dot last. Okay. Good. Possible null reference statement. Okay, be easy fast. You could just be like, have names dot first. Let's see what existed. Alright, well, that's the basics of how we're going to be able to use a linked list. Let's go to here. Leave each of these or O of n, even remove, because it may have to just go one element after another to search through it. What are we doing here? We're just saying if the list contains anything. Okay. Alright, so let's go ahead and count all of that. There's a lot of stuff that I don't want to just randomly get rid of. So we're gonna say, if names dot say mouse, which we know will, console dot write line, we should do something like this, mouse, or value, don't need to put anything, say true. Else console dot write line false. Oh no, that's run. Yeah, true. That in that as well. Obviously that will not exist. Just check to see if that exists. Obviously it doesn't. Nice. Alright, so let's check if something exists. Alright, so let's just do some kind of challenge then to challenge us, because this seems a little bit too simple right now. Alright. linked list challenge. Print the middle of a given linked list. Nice, I like that. So this is the question. Given a singly linked list. So maybe I shouldn't be using this. Yeah, let's try it. This is not. Okay. Create linked list C# without. What was it? Without generic? Without collection stuff. Okay, so we need. So, looks like a double linked list again. A singly linked list. I don't really know how to create this from scratch without having to use any kind of libraries. Okay, so SLL, single linked list, using generic internal class list, internal class node, private, data node next, is equal to null. Makes sense. Pointer next node, node next, return next, set next equal to value. Okay. Data stored in a node. Data. I don't understand what that means exactly. From what I understand, what a linked list is, it's just you should do something like, you know, node 1, node 2, node 3, you know, boom, boom, and one would another. This will be the leaf node. Do something like that. And this will be your dot next. The dot next will equal to value equal value dot next. Then this equals the next. Okay. Alright, so you're saying class definition for in C#, public class list node. Okay, I'm gonna go off of this document right here. Let's just get rid of all of this right now, because this is going way too easy. Now it makes sense why. So obviously we're going to be using this. Fix the music. Just public class list node. Public and data. Need a getter and a setter, which I have a vague understanding of what that is. Not in node, int node. We're into data. Public list node. Next. It was referencing itself. Public list node and data. Is that is equal to data. Is that next is equal to null by default. Assign the next one is null. Makes sense. Alright. So that was the first section of this. Alright. So implementing a single linked list, the single linked list itself needs to manage the nodes. It typically keeps a reference to the first node head. Here's how you might implement a basic singly linked list, which is not necessarily exactly what we want to do. Public class singly list SSL. Alright, call this public list node. We're gonna get the head. Private sets. That's pretty cool. I didn't know you can set something privately. Public void add first. So this tells me that we can just, add this to the beginning. So how this looks to work is list node is equal to new list node data. Next is equal to head. So new next is equal to head. They saying the next new node be this right here. And head is equal to new node. So in my mind, how that's working, we say, this is head next. This will be, new head. Head next. Full next, really. That's how I'm imagining that right now. Alright, so adding last is obviously much more difficult because you gotta find the leaf node, then you add it to the very next one. So change null to that, then you add the null to the end, I think. So look how that implementation looks like. So we're saying we have a new node. To create the node first, okay? If head is equal to null, obviously you don't have to go through anything, that'll be a constant time thing. Head is equal to new node. So else, which is not the case, list node, hold on. Alright, yeah, I think my workload will way down, whatever though. Alright, list node current is equal to head. Alright, so that's just saying the current value or add is equal to the head, which we understand that. So we're saying, well, while current dot next is not null, current is equal to next. Current equal the new node. Okay, so you pause this right now because this is a good song, or just change this. Yeah. So I think I'm understanding what linked lists are now. Obviously, we understand that a linked list, the value in it is that it points to, non-contiguous memories, so you can have, node 1 at memory slot 33, and then this could point to node 2 at memory slot 3. I don't know, something like that. And that could point at node 3 at memory slot 12, something like that. And then the linked list, like these is just how the memory works. And the linked list is what puts everything together. Linked list puts all of this together to where we slash manipulate data to how we need it. Yeah. Alright, so now that we understand that, adding the last node, this just makes it a little bit easier for me. So public, oops. Public void at last. And data. Alright, so, I'm back. So we have that, we're gonna say list node, new node is equal to new list node data. And we're gonna say if head is equal to null, showing that there's nothing in the list, then obviously head is gonna equal to new node. But most of the time that won't work. So let's go ahead and go back over here and, list node current is equal to head. Then you're going to say while current dot next not equal to null. Current is equal to current dot next. We're just saying, we're just trying to get the last value. Get out of loop once we hit the last value. Then after that, you're going to do current dot next is equal to new node. That should be a pretty simple thing right there. Yep. Alright, so We can add first, we can add last. Very, very, very useful. So now we need to be able to remove first. Alright, so we're gonna do public void remove first. Alright, so we're gonna call this, if not equal to null, meaning there's something in the linked list, and head isn't equal to head next. Just a reminder that the next is coming from up here. That's how we're always getting the next value. Removing first seems easy. Even though it's not on here, let's do remove last. It just did add last, so we should be able to, get rid of all the world, just have my mouse. Should be able to implement this pretty simply. So let's do, if head is not equal to null, do while hold on. List node current head. Now we're gonna say while current next not equal to null. Alright, so while is not next to null, current next current is equal to current next. Alright, so once we find the last one, I need to be able to remove that value. So let's, how would we do that? C# of last. Looking up something about it. So it looks like you just do current is equal null. Let's see what that looks like. Alright, so apparently I'm doing a few things wrong here, so I'm supposed to do a check, say head equal to null first, then if it is, you just return. And you need to do a check to say if head dot next is equal to null. Then you do head is equal to null, return. Then you do your list node, well, basically this node there. So now you have to do, well, current dot next is not equal to null, then current next, then otherwise current dot next equal to null. So you're checking one ahead every single time. You're basically saying, you know, one current next the one being checked. So basically, you know, this is always going to be the one that's being checked. And that'll be regardless, so that way when this is the case, then I assign current to this, then that like changes to null. Therefore, the last one is null, and we remove the last item. Makes sense to me. Alright, the next part of this is just printing out the linked list, which it seems like a pretty simple approach right here. And we're going to say public void print all. And we're going to do list node current is equal to head while current dot next is not equal to null. Console dot write line current dot data. And as a reminder for what data is, that is actually still right here in the list node part. Then after we put that out, we want to reassign this. Current is equal to current dot next. You don't really need to check next, because that means by the time you get the second to last one, we're not gonna go to the next value, we'll miss the last value. Alright. And that should be the simple approach to doing that. So we need to be able to use this. Right. Alright, so now we're going to do some testing. We're going to do public class program, boom, public static string. So list is equal to new. So a little more real estate on the page. Let's just go ahead and add some things. So list dot add first. We're doing integers, obviously, so let's add, 13 or 23 apparently. Right, so now we're going to do list print all, the little print all function that we created. See if this will actually work. Right line. Printing out linked list. Run. See if we get any errors or not. Nope, that worked. Sweet. Wow. A lot of stuff not being used. That's fine. Hey, all. Blah. Okay. Alright, so let's test out the, remove first. Let's remove first. Moved first. Item should be 8. Alright, so is it printing out backwards? What do I be printing out backwards? Let's look into that. What is that next? Saying that f head is equal to null. Return f head next is equal to null. Head is equal to head next is equal to null. Head is equal to null. Then return still. Outside current. That next is not equal to null. Yeah. This statement is not needed. Oh, maybe that's because we're always adding first, add first, so let's just push into the front. Okay, duh, add first, add last, so now if we did add last, it would be different. Okay, cool. We're good. First item. So now that we understand that, we understand that, you know, when the first item is 213, now it's 7, yep, okay. I guess a good test would be, you know, make sure add last works as well. I'll use some regex. Per time order we expect, and 20 is gone, so we're good on that. So we remove first works, let's make sure remove last works. Last. Yep, let's set it to 213. Alright. So, if we're going to try to do an approach of finding the middle value of a linked list. So let's look back at that. Because saying right here is there are 6 nodes in the linked list, so we have 2 middle nodes, 30 and 40, but we were trying the second middle node, and which is 40. So, alright, let's go ahead and return middle node. Public static void middle or length, or let's get the, you know, how many items are on here. So the public void internal length. So let's say public void int. and void means no return and so public, and we're gonna call this -1, just in case. Then we're gonna say list node current is equal to and total current length file. Then I think I'll just do current next and length plus so and so in our case, go ahead and delete this. Should be a 1, 2, 3, 4, 5, 6. We should have linked the 6 here, so we're gonna say console dot write line dot length dot run. So it's gonna 5. One, two, three, 4, 5, 6. That should be fine. Alright, so now that we got that, let's say .NET, not .NET, geez, public, and so now that I know how to reach an end, middle, node, so we have our end of, let's say, length plus that length. Maybe give like middle operator they can do. Of length 2 is equal to 0. This would mean it's like an even number. It is even because it's divisible by 2. That means we're gonna grab 3 and 4, I believe. So we're gonna say middle. So this means we're getting the second value of that. And uh, 2. Right line. That run. That would be number 4 like expected, so that's not done yet. Public. And -1, obviously. So we're just gonna get about middle. So now they have the middle index. So node current is while x is equal to while like that, then and equal to current next. Next. Data. Object reference not set to an instance of an object. And 32 is still give by middle, and 32 middle. And middle, public and everything. Node current is equal to head. And is equal to 1. Start on number 1. Let's see, index. All indexes. No. Current is equal to next. Okay, so you got middle is fine. Problem is up here. Very much the deep makeup and yellow sexy. Oh. Index plus 13. So in our case, what would be the 3, 4, 6? This is the very last value. This is not expected at all. One, two, three, 4 should be 32. Okay, so we're saying, what if we figure it was crazy? Oh, okay. Almost at a test case. And random and size equal to dot next 15. Right. Random size. Oops. That way you get a random number between 1 and 100 for the value. Add last, I like to add last. Number. Did I really put a 0 instead of a, put an O instead of a 0? Jeez. Let's see how that works. I'll get back so that way I can check my work. I had a little bit of stuff right here. Oh no, jeez. Console dot right line number Alright, so obviously it's going to be bigger output. Answer being 50 here. 1, 2, 3, 4, 5, 6, 7. This should be number 5. 1, 2, 3, 4, 5, which is 50, 50. Cool. So I was able to solve a simple problem. A simple linked list problem after learning how to build a linked list. I think this is good for the day. Alright.